In this section, we're going to use calculus to help us graph functions. Now, we've already seen that the first derivative tells us whether the function is increasing or decreasing, right? And we've been looking at ways of using calculus to find the maxima and minima of a function. And we also know that the second derivative tells us about the concavity. So we're just first of all going to review concavity and inflection points, and then we're gonna put this all together and work on graphing using calculus to graph functions. So you remember that the second derivative tells us about concavity, right? If the second derivative is greater than 0, it's concave up, right? And concave up just looks like a U. And if the second derivative is negative, right, less than 0, it's concave down, and the function has sort of an upside down U shape. Now, the point where a function changes concavity is called an inflection point, and you can see here in this this graph here that they show, the one on the left shows a function that's increasing and it's changing from concave up to concave down, and here on the right we have a function that's decreasing and it's changing from concave down to concave up, right? Now the point at which it changes concavity is called the inflection point. And if the function is, positive to the left and negative to the right, then it has to pass through 0 at some point if it's continuous. And so we can look for inflection points by setting the second derivative equal to 0. And then we have to test to see that there actually is an inflection there. Okay, so how do we locate inflection points? We find the second derivative, we set it equal to 0, and that gives us possible inflection points. That gives us the candidates for inflection points, but we have to test. We have to test that there actually is a change in concavity. So let's take a look at this first example. We have this function, and all we want to do is find the inflection points of this function. So let me scroll down just a little bit more. All right, so I need the second derivative. So first, I've got to find the first derivative, right? So let's take the derivative of this. So this is what, 3x squared minus 18x minus 48, right? That's the first derivative. Now, I'm not trying to find critical points, right? Because the critical points are necessary for finding the maxima and minimum. What I'm trying to find here are inflection points. So what I really need is the second derivative. So let's find the second derivative, right? We're going to get 6x minus 18. Okay, now I could factor that and make it 6 times x minus 3. And I'm looking for points where the second derivative is 0. So I set it equal to 0, and then we can see that the second derivative is 0 when x is equal to 3, right? Now that doesn't necessarily mean there's an inflection point there. This is just a candidate for an inflection point. In order to determine whether there actually is an inflection point there, we have to test for a change in concavity. All right, we're trying to find inflection points, so let's test it. So I'm going to write test. This is where we're testing for a change in concavity. Okay, we're just going to test this, and we're going to use the second derivative because that's going to tell us what the concavity is. And if I pick a point to the left, say I pick 0, right? And because that's an easy one. Now I could put it into either form of the second derivative, but I'll get a negative 18, right? So that's less than 0. That's telling me that it's concave down, right? Concave down, it looks like that. And if I test a point to the right of 3, let's say 4, now this one is easier to use the factored form. It's just that I guess it's not too hard to use either form in this case. But if I take 6 times 4 minus 3, then it's easy to see that this is just a 6. I don't really even care what the value is. All I care about is that it's greater than 0, which tells me that the function is concave up, right? So that looks like a u. And so now I have verified that there is an inflection point at x equals 3. So I'm just going to write IP. Sometimes I abbreviate inflection point IP at x equals 3. Okay? All right, I'll meet you in the next video for the next example.